right, Algebra 1 lesson. We're going to be doing section 6.1, properties of exponents. So properties mean sort of like rules and how they work and what you can do with them. You're going to need to upload your notes. Your notes should look just like mine, have everything I go over. Be helpful to put your name, the date, your period. So, all right. So I'm going to go ahead and just list several of the rules. There's going to be, I think, 7 altogether today. And I'll give the name of the rule, and then we'll talk. Then I'll show you what the rule is, and maybe show you a couple examples. So the first rule is going to be 0 exponent. And let's see, a little room. I'll show you how it works. So the 0 exponent says that anything raised to 0 power equals 1. But the base cannot be 0. The number on the bottom is called the base. So it can't be 0. Some examples, just real quick. Examples showing how this works. You could say x to the 0. It could be a variable. It could be a number, 5 to the 0. Anything to 0 power is going to be 1. All right, second rule. Negative exponents. So, if you have something to a negative exponent, you can, and usually want to, rewrite it as a positive exponent. It ends up in the denominator. A negative exponent, exponents are multiplication over and over again. Negative is division over and over again. It's in the denominator. So a couple quick examples. 4 to the negative 2 would be 1 over 4 squared. And then you could continue on and simplify it. Get 1 over 16. 3, product of powers. So that's another term that's used with exponents, is powers. So 4 squared, 4 to the power of 2. So this one, if you have 2 terms that you're multiplying times each other and they have the same base, they got to have the same number at the bottom, then you can combine them together by adding them. And I'll do a couple examples now. Some of these rules, you can totally prove them. So for instance, 4 to the 6th times 4 to the 3rd would be 4 to the 6th plus 3. So you add their exponents, and it's 4 to the 9th. Now, here's a quick way to prove this. 4 to the 6th, this isn't the work you want to show. These are shortcuts. 4 to the 6th is 4 times 4 times 4 times 4 times 4 times 4, right? And 4 to the 3rd is 4 times 4 times 4. So you could, these parentheses aren't necessary. You get rid of them and you say, oh, there's 4 to the 9. There's 9 4s times each other. So totally makes sense. Okay, rule number 4, quotient. Quotient of powers. So that's a fancy word. Quotient, fancy word for division. And it says that if you have something to a power divided by the same base to another power, you can combine them by subtracting. Now, you could also instead leave it in the bottom and say this one minus this one, and then it'll be in the bottom. Usually, you don't do top minus bottom, but you could do bottom minus top and leave it in the bottom. So for instance, 4 to the 6th over 4 cubed would be 4 to the 6 minus 3 would be 4 to the third, which you could simplify. 4 times 4 is 16, times 4 is 64. But again, this is a really easy rule to prove why it works. So if you have 4 to the 6, that's 4 times 4 times 4 times 4 times 4 over 4 to the third is 4 times 4 times 4. And you can reduce a pair of these 4s, pair of these 4s, pair of these 4s, and that's what's left. It's 4 to the third. So these are shortcuts. Number 5, power of a power. So it's like something has an exponent and then you raise it to another exponent. So this one kind of generically looks like this: a to the m to the n. So you have something to power and then you're raising all that to a power. And the rule is you multiply them. So for instance, if you have x to the fourth to the third, it would be x to the 4 times 3. It would be x to the 12th for your final answer. Now, this is another easy one to prove because you say, well, x to the fourth is x times x times x, right? To the third, which is going to be x times, to the third means we're going to multiply this times the same thing, times the same thing, and that's x to the 12. There's 12 x's there. So these rules, they make sense. Okay, let's do some examples, and then we'll have a couple more rules and some more examples. So example 1, let's see, or example, So A, let's say 6.7 to the 0th power. Well, it doesn't matter what you raise to 0th power, it's going to be 1. Okay. B, -2 in parentheses to the -4. Now, the negative in the parentheses makes a difference. If you had -2 squared, then that's just -2 times 2. The negative is separate from the power, order of operations. But if you have -2 squared, then that's going to be -2 times -2. So the parentheses around it mean the negative are part of that exponent. Now, the first thing that I think we'd like to do is rewrite it as a positive exponent. So we move it. Now, if you go back up here real quick, just to summarize these rules, if you have 0 exponent, it's going to equal 1. If you have negative exponents, you move it to the bottom. Okay. If you have a product of powers, you add them. If you have a quotient, you subtract. And if you have power of power, you multiply. So these rules right here, this is a good little sheet to look at when you're trying to learn these for the first time. This is going to be -2 times -2 times -2 times -2. So it's going to end up being a positive because you have 4 negatives, right? If every pair of negatives makes a positive when you multiply. And 2 times 2 is 4, times 2 is 8, times 2 is 16. So we could simplify it. C, 3 squared times 3 to the 6th. You would add these 3, so that's going to be 3 to the 8th. That's a pretty big number. So I mean, you could use your calculator today to simplify things. Now, I have this fancy calculator, so yours probably doesn't look like mine, but it functions similar. So 3 to the 8th, you'd say 3 and then use this caret symbol right here. On most calculators, this symbol right here, it's called the caret symbol, and that's what we use for powers. So that's 3 to the 8th. So that's how you do 3 to the 8th on this. And most simpler calculators also do it like that. So I'll probably simplify some of these answers. D, -4 to the 2 over -4 to the 7th. So these parentheses make a difference. That means the negative is part of the what's being raised to exponent. So the rule is you can do top minus bottom. Now, that's going to give you -4 to the -5. Now, I don't want a negative exponent, so I want to rewrite it as a positive exponent. So you move it to the bottom. Now, I was telling you up here earlier, we could have subtracted the 2 from the 7 and left it in the bottom, and we would have got the same thing a little quicker. Now, this is for sure going to, even without doing much work, we know it's going to be a negative answer. We can get rid of the negative in the parentheses because it's going to be negative times a negative times a negative times a negative times a negative. 5 negatives, it's going to be negative in the end. Over 1, 1 divided by 4 to the 5th. Now, that's a pretty big number. I don't expect you to necessarily do that on your own. So on my calculator, I could do 4 to the 5th power. That's 1024. 1024. In fact, I could have done -4. You got to put parentheses around it. -4 to the 5th power, and it gives you the negative. But it's in the bottom. When you move it to the bottom and there's nothing on top, you got to put a 1. Okay, E is going to be x to the 4th to the -3. So this is the power of a power. So we're supposed to multiply these. And so it'd be x to the -12. Now, I don't want negative exponents. My final answer is usually so. This is going to end up being moved to the bottom. There's nothing left on top, so there's just a 1 there. F, 10 to the 4th times 10 to the -6th. So you would add these. So that's going to give you 10 to the -2, which is going to be 1 over 10 squared, which is going to be 1 over 100. So a few examples there. I'm going to add a couple more rules. Power of a product. So power of a product. Power of product. So a product is two things multiplying each other, and if we take the power afterwards, it's kind of this one's kind of a simple rule. You just give it to both of these separately. They both get it. Okay. And so a quick example, 2x squared would be 2 squared, and x squared, which would be 4x squared. Final answer is simplified. And the next one is power of a quotient. Power of a quotient. And so quotient is a fraction, division. And then we're going to raise the whole result. So the top gets it and the bottom gets it. So that's a pretty nice simple rule. So here's a quick example. 2 over x squared. The 2 gets squared. The x gets squared. And we get 4 over x squared for our final answer. Now, I'm going to add a couple of rules here that don't exist, just so you know. So like we could do, and these are rules that people try to use that don't actually work. Power of a sum. So that'd be like a plus b to the n. And some people think, oh, well, I could just give that to the a and I could give that to the b. No, that does not work. So this is not, you actually have to distribute it. You got to FOIL it. Same thing for difference. So if it were subtraction, you can't just give it to each of them separately. It doesn't work. It will give you the wrong answer. Okay, so those are not rules. Just throwing that in there. Let's try a few more examples, and I want you to try these. These ones are a little more complicated. They have more than just one thing with the power. So write these down, pause the video, try them yourself, then unpause it and see if you got the right answer. So this first one is going to be 15 c to the -8 d to the 0. So that whole problem right there. I want you to write it, simplify it, no negative exponents, your final answer. So see if you can try it. Pause the video. Okay, now this 15, some people think, oh, well, it has a -8. Nope. If there are parentheses, then it would also get the exponent. But exponents are only applied to what they're right next to. So this is a power of 1. So that's going to stay on top. The c to the negative 8, we're going to move to the bottom to make it positive. D to the 0 is 1. So our final answer is going to be 15 over c to the 8th. That's the best answer. Okay, let's try another one. P to the negative 8th over 7 to the negative 2, x to the negative 9. So pause the video, see if you can do it on your own. All right, now if it has a negative exponent, it switches, it moves spots. Now if it's in the bottom of the negative, then it goes to the top to be positive. So if it's a negative exponent, it's just got to switch. If it's in the top, it goes to the bottom. If it's in the bottom, it goes to the top. And then 7 squared is 49. You can simplify that. Everything else cannot be simplified. So that's your final answer. Okay, let's try another one. 4 to the negative 3 times 4 to the 5th. So pause video. See if you can do this one on your own. Okay, now there's a couple ways we could do this. We could combine these first by adding them, which I kind of think is the best way. And it's 4 squared, which is a 16. Now, just to show you, you could apply these rules sometimes in other order. So if you wanted to, you could have said, okay, well, let's rewrite this. The 4 to the 5th is on top. The 4 to the negative 3 ends up on bottom as a positive exponent. Then we use the rule where you subtract the bottom from the top. 5 minus 3 is 4 squared is 16. Same answer. Now, I kind of like the way I did it first better, but it's up to you. 4 to the x in parentheses to negative 4. Pause the video. See if you guys can figure it out on your own. This will help you do the homework quicker. Okay? Now, what we said is the 4 gets it and the x gets it. This one also has a couple ways of doing it. So then we could move this to the bottom. We move this one to the bottom. There's nothing on top, so we need to put a 1 there. Now, 4 to the 4th is 4 times 4 is 16, times 4 is 64, times 4 is 256. You could try it, on paper. I actually skipped a couple of examples I want to show you guys. Okay, you could do 4 times 4 is 16, 4 times 4 is 16, so that gives you 64. 6 times 6 is 36. Carry the 3. 6 times 1 is 6. Add 3 is 9. 0, 6, 1, 6, 15. Carry the 1, 256. There were a couple examples I meant to show you after this, but I sort of missed them, so I'll squeeze them in right here just to make sure you guys are prepared. So g negative 1.5 y squared. So we could do the negative 1.5 squared, and we could do the y squared. Now, negative 1.5 squared, well, that's going to be a positive answer for sure, right? Now, 1.5 squared is 1.5 times 1/5. You guys can use a calculator, but I think you guys should be able to do this kind of work too. Vertical multiplication with decimals, you kind of ignore the decimals at first. 5 times 5 is 25. Carry the 2. 7, 0. 1 times 5 is 5. 1 times 1 is 1. You add them. So you're doing it like regular multiplication, and you count these 1, 2 spots all the way back to the right. So you start to the right and come back the total amount. So that's 2.25 y squared. It's going to be positive. Now, my calculator, I could do it on my calculator. I could do, I have to put in parentheses if I do it like this, negative 1.5 to the second power. Now, the other way you could do it, by the way, if your calculator doesn't have this caret symbol you can't figure out, you could just do negative 1.5 times negative 1.5. That's what squared is, right? A over negative 2 to the third. So it's going to be a to the third over negative 10 to the third. Now, negative times a negative times a negative is for sure going to be negative. 10 to the third, 10 times 10 is 100 times 10 is 1,000. Right? By the way, this one right here, I was going to say, originally what we could have done is is fix the exponent first and then give it to both of those to get the same answer. I kind of like that. I like kind of getting rid of negative exponents right away. One last one. 2x over 3. So I did mean to do these right here. Let's try this last one. So there's a couple ways to do this. We could say, okay, well, we're going to give the top it, and we're going to give the bottom. And we can say, well, let's fix the negative exponent. So they got to switch. If it's on the bottom, it goes to the top. If it's on top, it goes to the bottom. And then 3 to the third, 3 times 3 is 9, times 3 is 27. And then the 2 gets it, and then the x gets it. So 27 over 8x cubed. But what you could have done right at the beginning, this is what I would like to do. You could do it like that. You can say, okay, we need a, because it has a negative exponent, everything's going to get it. Let's move what's on the bottom to the top and top to the bottom and just make it a positive exponent right now. That'll work. You will get the same thing. You'll start seeing the same work we did. Okay, that's it. Today's assignment is monitoring progress. You use the student dynamic ebook. You need to write all these down. Page 292, problems 1 through 14 all. You can check each answer 3 times as you do it. Or actually, no, I'm sorry, you can't check your answers. But there, next to each one is a little blue play button. You got to be zoomed all the way out, though, to be able to play it. And then it'll give you a video showing you exactly how to do each problem. So if you're stuck or you're just not sure if you got it right or not, you can do that and get every one of them 100% right. So go ahead and do your best.